And we're back, and we're gonna try to finish up the part about vacuum tube principles. We want to move on to, let's see, way down here. There's a lot still to talk about, but we want to get to the next top. Oh my God, this goes on forever. We want to get to oscillators because we got to move through this. And again, I'm not somebody who is trained in electronics, especially this era at all. So I'm trying to give this in a book report kind of view and just tell you what's in here and try to read through and try to understand some of the stuff in here, but there's quite a bit going on. The next little section was on feedback. So if you've ever been around an old PA system or a guitar amp where it's, they get it to feedback. What exactly is feedback? I don't know if these are power, if this is referring to a power amplifier, but the feedback theory explained is this. So we can cover it here. There are two types of feedback. If the voltage that is inserted in the grid circuit is 180 degrees out of phase with the signal voltage acting on the grid, the feedback is called negative or degenerative. On the other hand, if the voltage is fed back in phase with the grid signal, the feedback is called positive or regenerative. So there's degenerative feedback and regenerative feedback. With negative feedback, the voltage is fed back and opposes the signal voltage. This decreases the amplitude, which I guess would be the power, or how strong the signal is, of the voltage acting between the grid and the cathode. With a smaller signal voltage, of course, the output is also smaller. The effect of negative feedback then is to reduce the amount of amplification. So while it would be natural to assume that there could be no point in reducing amplification by negative feedback, it does have uses. The greater the amount of negative feedback, when properly applied, the more independent the amplification becomes of tube characteristics and circuit conditions. This means that frequency response characteristics of an amplifier becomes flat. That is, amplification tends to be the same at all frequencies within the range for which the amplifier is designed. So the same amplification across all frequencies using negative feedback. I guess that's good. You want to have the same type of amplification and the same amplification of a signal throughout all the frequencies. Seems pretty balanced, I guess. And let's just do a quick dealy bob on positive feedback. Positive feedback increases the amplification and becomes fed back voltage, adds to the original signal voltage, and the resulting larger voltage on the grid causes a larger output voltage. It has the opposite characteristics as negative feedback. The amplification tends to be the greatest at one frequency, depending on the particular circuit arrangement, and harmonic distortion is increased. So at this point, I'm just going to talk over myself. Perhaps a positive feedback system amplifier is probably designed specifically for one specific frequency for a higher output, as opposed to a negative feedback, which is for a broader range of frequencies. I keep thinking about guitar amplifiers, like when the guy is running a Marshall stack and cranks his amp until it distorts, could that be a positive feedback deal? I don't know. Or is it negative? Okay. And here's a nice picture of a vacuum tube. This is like the old school, what I was used to seeing and playing with when I was a kid. It kind of shows where the grid is, the central grid, the plate, the heater, and the cathode. A lot of people don't know what these are anymore, but if you're into old radio equipment, you'll see these. This is a typical glass. There's a name for this type of glass style of tube. forget what they call it, but anyway, it kind of looks like an 811A or an 807, or is it 807? Or, I'm not sure. But they talk about different. Oh, this is a screen grid tube, and gonna probably just kind of let this go for now. They talk about variable. I think that's conductance, mutual conductance tubes, other types of amplifiers, grounded grid. I don't even know. This is too much for my little junior mind to understand. And again, these could be topics to go over again in more detail later. Grounded grid amplifier. And there's some more information about filament hum, cathode follower. And this is great stuff. Cathode bias. So we're putting negative voltage on the cathode. Wait a minute. Let's just do a quick look at cathode bias, because I just read this one little part here. So in the simplified amplifier circuits discussed in this chapter, grid bias has been supplied by batteries. So yeah, they show batteries. If I was to scroll up, or if you look at the earlier videos, they were showing a battery in the circuit supplying current negative grid bias via a battery. However, it is seldom obtained that way. In an actual piece of equipment that operates from the power line, cathode bias is typically used. So, looks like we're powering the grid with AC? I'm not sure. Cathode bias method uses a resistor connected in series with the cathode, as shown at R right here. That's the cathode in series with the capacitor. The direction of plate current flow is such that the end of the resistor nearest the cathode is positive, which is right here. The voltage drop across R, therefore, places a negative voltage on the grid. The negative bias is obtained from the steady DC plate current. Okay. Well, isn't that interesting? So instead of using a battery, they're still putting negative voltage on the grid. However, I just got lost. It is a ton of information. And here we have screen supply. We have mercury vapor rectifiers, beam tubes, grid control rectifiers. What is a beam tetrode? Beam tetrodes are tetrode tubes constructed in such a way that the power sensitivity is very high. Beam tubes are useful as both radio frequency and audio frequency power amplifiers and are available in output ratings from a few watts up to several hundred watts. The grids of a beam tube are so constructed and aligned as to form electrons traveling to the plate connected into connected beams. This makes it possible to draw a large plate current at a relatively low plate voltage, and also reduces the number of electrons that are captured by the screen. So I guess a power tube, like the finals on a TS-830S or whatever back in the good old days, are beam tubes, I guess. Multi-purpose tubes. So, in a radio, an old tube radio, there are lots of tubes. There are big tubes, there are small tubes, there's 6L6s, 6146s, 12AX7s that do different things. And it was just a real basic stuff for you to read about, for me to read about, to kind of basically understand that. Wow. So there you go, folks. That's the finale right now, at least for now, on vacuum tube principles in Chapter 3. Next, we're going to move on to oscillators.